Good evening everyone. Am I audible? Good evening all. Am I audible? Yeah. Good evening all. I warmly welcome you all to my session. Yeah, okay. Let's wait for a few minutes. Let's everyone join. Let's wait for a few minutes. Good evening. Vishnu Prakash, good evening. Shravani, good evening. Chan, good evening. Sabha, okay. Okay. Shall we start the class? Shall we start? Just drop S in the chat box, please. Yeah, good evening. Okay. So in yesterday's class I told you, right, so two tabular columns are not visible. So here it is. So this is the difference between ESP01, ESP12E node MCU and VMOS D1 mini. So coming to ESP01 module, here you will have only 4 GPIOs. In ESP12E node MCU, you will be having 11 GPIOs. And in VMOS D1 mini, there is 11 GPIOs. And coming to ADC, ESP01, ESP12E, VMOS D1 have one ADC which is 10-bit resolution. And coming to flash memory, ESP01 only have 1 MB. ESP12E node MCU have 4 MB. And similarly, VMOS D1 mini have 4 MB. So is it breadboard friendly? ESP01 is not. And the remaining two is yes, which is breadboard friendly. And ESP01 doesn't have USB to serial converter. But these two has USB to serial converter. You can connect your microcontroller using USB to your PC or a laptop. So size, according to size, this is 24.75 mm cross 14.5 mm. For 12E there is 48.55 cross 25.6 and 34.2 mm cross 25.6 mm. And then what is the best pins to use and what is the purpose of each pin? So one important thing to notice about ESP8266 is that the GPIO number doesn't match the label on the board cell screen. For example, D0 corresponds to GPIO 16 and D1 is correspond to GPIO 5. So if you want to connect your GPIO 5 pin to something like ACL, in the sense you have to give connection to the D1 pin. So this table shows the correspondence between the label on the cell screen. Okay, I'll show like this. Okay. So GPIO number as well as what pins are the best to use in your projects. and which one you need to be cautious. The pins highlighted in green are okay to use. The one highlighted in yellow are okay to use, but you need to pay attention for these yellow colored pins like high at boot, okay. For these pins you have to pay attention. So because they may have unexpected behavior mainly at boot. So these pins highlighted in red are not recommended to use as input or output. This pin should be used as only RX for receiving purpose. This pin is only used for transmitting purpose. You should not use these two pins for other purpose. Similarly, A0. So, GPIOs connected to flash chip. Which GPIOs are connected to the flash chip? GPIO 6 to GPIO 11. Pin number 6 to 11 are usually connected to the flash chip in ESP8266 port. So, these pins are not recommended to use. And coming to the pins which are used during boot, the ESP8266 can be prevented from booting. If some pins are pulled low or high, the following pins are on boot, which is GPIO 16 pin is high, which this pin is high at booting, and GPIO 0 boot failure if you pull this at low, and GPIO 2 this pin is high on boot and the boot is failure if it pulled to low. And coming to GPIO 15 boot failure if you pulled it high. And GPIO 3 pin is high at boot but failure if you pulled it at low. And are you guys able to see the screen? It is visible. Is this visible? This page? Am I audible? Are you guys able to see this page? Am I audible? Okay. So on coming to analog input, the ESP8266 only supports analog reading in one GPIO, which is A0. This GPIO is called ADC 0 and it is usually marked on the SIL screen as A0. The maximum input voltage of the ADC 0 pin is 0 to 1 volt. So if you are using the ESP8266 bare chip, in the sense the voltage maximum input voltage is between 0 to 1 volt. So if you are using a development board like ESP8266 12 node MCU kit, then the voltage input range is 0 to 3.3 volt because these boards contains an internal voltage divider. Then coming to onboard LED. So most of the ESP8266 development boards have a built-in LED. So this LED is usually connected to GPIO 2, which is D4. So your D4 pin is your inbuilt LED. Suppose you want to blink your LED, in the sense if you don't want to use the external LED, in the sense you can use inbuilt LED. In program you just give the inbuilt LED, so the inbuilt LED will work. You don't need to connect the external LED, resistor and jumper wires and all. So coming to reset pin. So when the reset pin is pulled low, the ESP8266 resets. So this is the same as pressing the onboard reset button. and GPIO 0 pin. When this pin is pulled low, it sets the ESP8266 into bootloader mode. So this is the same as pressing the onboard flash or boot button. And I2C pins, clock and data. So D1 and D2, which is GPIO 5 and GPIO 4, are I2C pins. So it doesn't have hardware I2C pins, but it can be implemented in software. So you can use GPIOs as I2C. Usually the two pins used as I2C pins. GPIO 5 is for serial clock and GPIO 4 is for serial data. And coming to SPI pins, here it is serial clock, master in slave out, master out slave in, and chip select. So these 4 pins are used as SPI pins. And then pulse width modulation pins. So ESP8266 allows pulse width modulation in all input output pins. You can use GPIO 0 to GPIO 15. You can use any pin in between these two pin number from 0 to 15. So pulse width modulation signals on ESP8266 have 10-bit resolution. And then coming to interrupt pin, it supports interrupts in any GPIO except GPIO 16 because this pin is used to wake up the ESP8266 from deep sleep. So if you are using deep sleep in your code, in the sense, the GPIO 16th pin is used to wake your ESP8266 up from deep sleep. So you should not use this pin for the interrupt purpose. At last, power pins. Usually all boards comes with power pins, 3 volt, ground and V-in. If some sensor will support only in 5 volt, so for that purpose you should go for V-in pin. Some sensor will work at only 3 volt, so for that purpose you can go for 3 volt. So if you are not providing power through the USB port, you can use these pins to power the board, or to get power from other peripherals if you are powering the board using the USB port, in the sense. So this is all about the pins and its importance. So are you guys understood this? Are you guys understood this concept? Are you clear with this? Shall I move to the today's topic? So yesterday someone is asking me for a ESP8266 package link, but I forgot to provide that. I just paste that link in chat box. If you want to download, in the sense, you can use that link. So this, is the ESP8266 package link. Using this, you can install your ESP8266 package in your Arduino IDE. So now we will see the today's topic. So, what we are going to learn today? So, first let me give a short introduction about these topics: ADC, pulse width modulation and deep sleep. So, first one is ADC. It is a process by which analog signals, which means continuous voltages, are converted into digital signals, which is discrete values. So that can be processed by a digital system like a microcontroller. So in ESP8266 there are one or more ADC channels that can be used to measure analog signals. So the resolution of the ADC in ESP8266 is 10 bits, which is 0 to 1023, which means that it can represent analog voltages as a number between 0 and 1023. You can vary values in between them. Then coming to pulse width modulation, it is a technique which is used to control the power delivered to electrical devices like motors and LEDs. So in ESP8266, pulse width modulation can be implemented on any GPIO pin. I already told, right? So the duty cycle of the pulse width modulation signal determines the amount of power delivered to the device. So the duty cycle can be adjusted by changing the pulse width of the signal, which can be done using the analog write function. And then coming to deep sleep, it is a low power mode that can be used in ESP8266 to conserve power. For that purpose we are using deep sleep. So when the device is not actively processing data, so in deep sleep mode, the device shuts down most of its component and goes into a sleep state. So you can save power, right? So this mode can be useful in battery powered devices. So where power consumption is a concern. To exit deep sleep mode, the devices needs to be reset or wake up by an external event. So let's see one by one in detail. So first, ESP8266 ADC, we are going to read analog values with Arduino IDE. So ESP8266 12E have one ADC pin that is easily accessible, which is A0. This means that those ESP8266 boards can read analog signal. When referring to the ESP8266 ADC pin, you will often hear these terms interchangeably. ADC like analog to digital converter, T out, pin 6, A0, analog pin. So all these terms refer to the same pin in the ESP8266, which is A0 ADC pin. And coming to its resolution, the ADC pin has 10-bit resolution, which means you will get values between 0 and 1023. And coming to input voltage range, the ESP8266 ADC pin input voltage range is 0 to 1 volt if you are using the bare chip. However, most ESP8266 development boards comes with an internal voltage divider. So the input range is 0 to 3.3 volt. So ADC voltage range in ESP8266 development boards is 0 to 3.3 volt. For example, you can take ESP8266 12E node MCU kit, VMOS D1 mini. And the ADC voltage range in ESP8266 bare chip, in the sense it is 0 to 1 volt. For example, ESP07 chip, ESP12E chip, like. And with the ESP8266 12E node MCU kit and other ESP8266 development board, it is very easy to access A0 pin. Here this is the A0 pin, here this is the A0 pin. You simply connect a jumper wire to this pin, that's all. So if you are using the bare chip like 07 or 01, in the sense, you need to solder a wire to that pin. So you can go with this. So now what we are going to do is, we are going to write a code. So open your Arduino IDE. I am going to write a code here. So first what we are going to do is, first we are going to initialize analog pin. For that I am going to give constant, data type is integer, analog input pin, right? So I am going to define A0. So why I am declared constant here, in the sense it allows a programmer to tell the compiler that a particular variable should not be modified after the initial assignment in its declaration. So once you define a pin using constant, in the sense you should not change in between the program, the pin number. So that's why we give constant, and the data type is integer, and the pin variable name is analog input pin, and the pin number is A0. So then we are going to create a variable called sensor value, the same integer data type, sensor value equal to, I am going to put 0. So the potentiometer value will be stored on the sensor value variable. So then what I am going to give is void setup function. So there are two functions, one is void setup function and another one is void loop function. So whatever you given inside the void setup will run only once. So whatever you give inside the void loop function will continuously run until your board got off or until you stop the program. So if you want to run only one, in the sense you should give it inside the void setup. You want to continuously run your program, in the sense you should give inside the void loop function. So inside void setup, I am just going to give serial begin, which is for communication purpose. We have to start communication, right? So for that purpose, I am going to give serial begin. Inside I am going to give 9600, which is nothing but baud rate. So then it's nothing for it's over for void setup. Next we move to void loop. And guys are not able to see my screen. One minute. Is it visible to you guys or not? Screen it not visible. Okay, so riddle quest ma'am port or kahal. So if you want to find out your port, in the sense, just go and search device manager. So here you will find your port. So go to device manager. Here you will find out your port number. So click port. Under you will find your, so if you plug your USB cable to your laptop, in the sense it will show like this, USB to UART bridge. You can find your corresponding port number here. The same thing you will find out here also. So component 3, select this. Is it clear? So inside void loop, first we have to read analog pin value and we have to store it in a variable. So sorry. Okay. Here sensor value, here I am going to read analog read. Inside I am going to give analog in pin. So in the loop we read the analog value by using analog read function and passing the analog in pin as an argument. So the value is saved on the sensor value variable. So now I am going to print the value. For that I am going to use serial dot print. Here what I am going to give is, we are going to use potentiometer, right? So I am going to give pot value. Serial dot print ln. Here I am going to print the sensor value or pot value, whatever. So now I am going to give a delay of 1000 millisecond, which is for 1 second. So this is our code. Before that, make sure you have connecting the corresponding microcontroller or not. So 12E and port 4. First let us verify it. It will take some time to verify. Let us wait for a few seconds. It took some time to compile and verify. So before uploading your code into your microcontroller, please make sure that if you have error in the sense serial, we have give the spelling mistake here, right? So serial, sorry. Okay, verify it again. Make sure that your code is error free or not. Then go for compiling. Okay, now our code is error free. So now let's move to the hardware part. Is the screen is visible? Is my screen is visible or not? Are you able to see the hardware? Okay. So if you take your potentiometer like this in the sense, so the first pin from right. So this is the analog pin. Connect this pin to your A0 here. Sorry. This is VCC pin. The brown wire is the VCC pin. Connect this pin to Vin or 3.3 volt. You can give any. So the center pin is the A0 pin. and the last orange pin is the ground pin. So this is our connection. So now let me upload the code into the microcontroller. So let us wait for a few seconds to upload our code into a microcontroller. Here I am using C language, embedded C. So it is compiling. Yeah, if you open your serial monitor here in the sense, so this is your serial monitor, click this, you will have your output here. So you have to set the baud rate 9600 here also. Make sure that you have select the correct baud rate. Here it's your output. If I twist my potentiometer slowly, like in the sense, it will, the output will be vary. So here 135, 136. So here 1024, 720. So this is our output. Is it clear? Shall I move to the next topic? Okay. So now let's move to the second topic. Here I am going to erase this program. Let me open it. So what next is, now we are going to interface LM35 temperature sensor with ESP8266. Sorry, I mentioned here 32. We are not going to interface it with 32. We are going to interface it with ESP8266. So first, what is LM35 temperature sensor? So the LM35 is a temperature sensor that outputs an analog voltage which is proportional to the temperature in Celsius. So it is a popular choice for temperature sensing applications. So due to its accuracy, due to its low cost, and it is easy to use. So if you are seeing pin out in the sense, the LM35 sensor has 3 pins. One is VCC, one is ground, and the center pin is output pin. So the VCC pin is connected to the positive supply voltage, and the ground pin is connected to the ground, and the output pin provides an analog voltage which is proportional to the temperature. So it operates over a temperature range of minus 55 degrees Celsius to 150 degrees Celsius, and the output voltage ranges from 0 volt at minus 55 degrees Celsius to 1.5 volt, and at 0 degrees Celsius to 5 volt. So the output voltage is linearly proportional to the temperature with a sensitivity of 10 millivolt per degree Celsius. So the output analog voltage can be converted to digital using ADC, so that a microcontroller can process it, right? So for that purpose we are converting voltage into a digital. So for that, let us write the code for LM35 sensor. So open your Arduino IDE. Here first I am going to initialize a float variable called Vref. I'm going to give 3.3. So this variable represents the voltage reference for the ESP8266 ADC. So again I am going to initialize a float variable. Called resolution. By dividing Vref by the maximum possible value of the ADC, which is, so I am going to divide it by Vref divided by 1023. So this calculation determines the resolution of the ADC or the smallest voltage which is incremented that can be detected by the ADC. So inside void setup, for communication purpose I am going to give serial dot begin, baud rate is 9600. So inside void loop, now we have to read the sensor pin and have to store it in a variable, right? So again I am going to give a float temperature analog read of A0. So here we read the analog voltage from A0 using the analog read function and store it in a float variable called temperature. So to convert ADC reading to a voltage value, we need to do one calculation, which is temperature equal to temperature into resolution. So it multiplies the temperature value by the resolution value to convert ADC reading to a voltage value. For that purpose we are doing this calculation. But now another calculation for converting temperature value in degree Celsius. For that I am going to give temperature equal to temperature into nothing, just 100. So it multiplies the voltage value by 100 to convert it to a temperature value in degree Celsius. So now let's print the value in serial monitor. So serial print of temperature, serial println. So inside just give degree Celsius. So now we have to give a delay of 1000 milliseconds. So this is our code. Let me verify it first. Let us wait for a few seconds. Let it be compiled. So our code is error free. So now let's move to the hardware part. Before that, please make sure that you have selected correct port and board. So yeah. So this is our LM35 temperature sensor. So the flat, you have to face the flat side. So the first pin from left, this pin is VCC, the center pin is A0 and the last pin is ground. Let me place it in a breadboard first. So the first pin, which is VCC, let's give 3 volt. So the center pin we have to give it to A0. So the last pin is ground. So this is our connection. Now let us upload it to our microcontroller. It is compiling. Let us wait for a few seconds. Are you guys able to understand it? Is it clear? It is compiling. Yesterday we saw about the installation part. Have you done your installation in your PC or laptop? Have you tried that? Attendance link will be provided. Please wait. Have you installed ESP86 package in your laptop, or have you ever used this? Yeah, okay. Thank you for your response. Yeah, it's compiling. Yeah, thank you all for your response. Yeah, it is compiled. Now open your serial monitor. Here you will get your output. Now it is 4.52 degrees Celsius. If you rub your hand and place it in a finger in your LM35 sensor, in the sense it will vary according to the temperature. So hold like this. It will vary. So this is our output. Is it clear? Shall I move to the next topic? Yeah, okay. So next is pulse width modulation. So SP8266 node MCU pulse width modulation with Arduino IDE. We are going to dim our LED using analog. So now we are going to see how to generate pulse width modulation signals with ESP8266 node MCU using Arduino IDE. So as an example, here we will dim the LED brightness by changing the duty cycle over time. So the ESP8266 GPIOs can be set either to output 0 volt or 3.3 volt. So but they can't output any voltages in between. However, you can output fake mid-level voltages using pulse width modulation. So if you alternate an LED's voltage between high and low very fast, your eyes can't keep up with the speed at which LED switches on and off, right? So you simply see some gradations in brightness. So that's basically how pulse width modulation works. So by producing an output that changes between high and low at very high frequency like this. So and there are two important parameters associated with pulse width modulation signal. which is duty cycle of pulse width modulation. So as we know, a pulse width modulation stays on for a given time and stays off for a certain time. So if you give 50% in the sense, 50% it will be in off state and 50% it will be in on state. So if you give 100 in the sense, it will be in full brightness. If you give 0 in the sense, it will be full dim. So the percentage of time for which signal remains on is known as the duty cycle. So if the signal is always on, then the signal must have a 100% duty cycle. So the formula to calculate the duty cycle is this. Duty cycle is equal to turn on time divided by turn on time plus turn off time. So the average value of the voltage depends on the duty cycle. So as a result, the average value can be varied by controlling the width of the on of a pulse. So next is frequency of pulse width modulation. So the frequency of pulse width modulation determines how fast a pulse width modulation completes a period. Period means on time plus off time. It is a period. So the frequency of pulse width modulation can be calculated as this. So frequency is 1 divided by time period. Period means on time plus off time, and time period is equal to on time plus off time. And then the most important thing is analog write function. So to generate a pulse width modulation signal on ESP8266 pins with Arduino IDE, we have to use analog write pin. Inside a parameter you have to pass the pin and value. So pin means we can use pins from 0 to 16, and value means the value is an integer between 0 to 255. So it should be in a range from 0 to pulse width modulation range, which is 255 by default. When value is 0, pulse width modulation is disabled on that pin. So a value of 255 corresponds to 100% duty cycle. You can change the pulse width modulation range by calling this function. If you want to change in the sense, by calling this function, you can change your pulse width modulation. And then coming to analog write range, inside an argument you have to pass new range. So and by default, ESP8266 pulse width modulation frequency is 1 kHz. You can change pulse width modulation frequency with this function. At last, analog write frequency inside a parameter new frequency. So the valid values are from 100 Hz to 40,000 Hz. So now let's move to the coding part. Open your Arduino IDE. So first what I am going to do is, I am going to start with defining LED pin which is attached to the pin D1. So constant, data type is integer, LED pin, I am going to give D1. Now void setup. Here we don't do any communication purpose, like so we don't give anything inside the void setup. Let us leave it blank. But in void loop function, now we have to create a for loop to vary the duty cycle between 0 to 255 to increase. First we are going to increase the LED brightness. For that I am going to make a for loop. So inside int duty cycle, I am going to initialize it first, which is 0, and then duty cycle is lesser than 255, which is expression. At last, duty cycle, we are going to increase it, right? So for that we have to give increment. So inside I am going to give analog write of LED pin duty cycle. We have to pass the argument as LED pin and we have to give the duty cycle. So this function uses pulse width modulation to vary the brightness of the LED by rapidly turning it on and off at different duty cycles. For that I am giving analog write inside LED pin and duty cycle. Is it clear? So the same thing. Now I have to give a delay of, I am just going to give 10 millisecond. So now another for loop. Now which is for to decrease the brightness. I am going to give the same thing, just I am going to copy this and I am going to paste this here. But instead of 0, we are going to decrease the brightness. For that I am going to give 255 and here we have to give greater than 0 and here we have to give decrement symbol. So initialization, expression and the increment decrement function. So at last, so inside the same thing, analog write LED pin and duty cycle and delay of 10 millisecond. So this is our code. Let us verify it first. Let's wait for a few seconds to verify. Sorry, I gave duty cycle. It is duty cycle. Verify it again. I think attendance link is already provided. Please check it once. Okay, now our code is error free. Now let's move to the hardware part. So here I connected LED and resistor. So the positive side of the LED you have to place your resistor like this. So here we define D1 pin, right? So in the positive side D1 here. So the negative side you have to place it to ground. So here it is. This is our connection. Let me upload the code into our microcontroller. Let us wait for a few seconds. It is compiling. Hello. Attendance link போடலையா நீ? இருமா கேட்டுட்டே இருக்காங்க போடு. Attendance link will be provided in few seconds. Sorry for that. Please wait for few minutes. Attendance link will be provided in the chat box. Yeah, I will provide you the attendance link. Please wait for few seconds. Yeah. Here is an attendant link. So it is compiling. So here it is our output. Are you able to see this? It will increase and decrease according to our duty cycle. So you can see this here. Now it is increasing. Now it is decreasing. So this is our output. So our next topic is deep sleep, but I think we don't have enough time. Let's see the deep sleep topic in next session. Let's wind up it with pulsed modulation and ADC. Are you guys understood the topic ADC and pulsed modulation? Is it clear? Is it clear? We will talk about the deep sleep topic in tomorrow's session. If you guys understood the topic about ADC and pulsed modulation in the sense, just drop yes or thumbs up emoji in the chat box, please. Okay. Thank you all for your response. Let's wind up it with here. Thank you everyone.